Hey, good morning, everyone. Just a quick recap from last week before we start the lesson on dividing today. Let's just review multiplying. And remultiplying when we did algebra was numbers times numbers and letters times letters. And multiplying with radicals was numbers times numbers and radicals times radicals. The difference with the radicals is when you end up with a number for a mixed radical, such as 3 root 90, we still have to make sure we can simplify. So today's lesson is on dividing. And let's look at some examples with numbers and look at some examples with radicals. The first one here is 12/18. And when we go to divide radicals or divide numbers, we always want to make sure we just divide the top number by the same thing. So I see 12 and 18. I might just divide those both by 6 to begin with. Not divide by 6, sorry. Divide them both by 2. 12 divided by 2 is 6, 18 divided by 2 is 9. Now I recognize that both these numbers divide by 3, so I might just divide them by 3 and get 2 and get 3. So 2/3 is your best answer. When I talked about 12 and 18 divided by 6, I could have divided 12 by 16 and got 2, and 18 divided by 6 and got 3 in one step. So again, whether we're doing radicals, we're doing algebra, sometimes we can do things in one step, sometimes we do things in 2 steps. 24 and 16. 24 and 16, we're going to divide numbers by numbers, letters by letters. And again, when you're looking at letters, we're going to use like laws of exponents here. So dividing algebraically, we're going to have x cubed divided by x, subtracting the exponents. But first of all, 24 and 16. 24 and 16 both divide by 8. 24 divided by 8 is 3. 16 divided by 8 is 2. I have x cubed in the top and x in the bottom. X cubed divided by x, I still have x squared. So when we have our answers, whether it's algebraic or radical later on, sometimes we just get fractions, sometimes we have fractions with radicals. This is an example of having fractions with letters. 12/16, x squared x, y, and y cubed. Again, you have to put the same things together. The numbers go with numbers, letters go with letters. In other words, x's go with x's and y's go with y's. 12 and 16 both divide by 4. 12 divided by 4 is 3. 16 divided by 4 is 4. X squared divided by x. There's x on the top, right? Because there's 2 on the top and 1 on the bottom. 2 minus 1 means there's an x on the top. Look at the y values, y cubed in the bottom, only y on top. When I simplify this expression, I have y squared left in the bottom. There's 3 y's in the bottom, 1 y in the top. Divide them, cancel them out. Our answer then is 3x, 4y squared. Numbers with numbers, letters with letters. Let's apply that now to radicals. We're going to do a couple here together. I'm going to ask you to pause the video, and then I want you to try quite a few of these on your own. So if you look at A, root 18 and root 6, it's radical divided by radical. These both divide by 6. So if you take 18 divided by 6, you now have square root of 3. If you take 6 divided by 6, you have square root of 1. But we don't usually write square root of 1 because it just means whole number 1. We don't usually write things that divide by 1, so this answer is just square root 3. What we did was we looked at the radicals, and we knew the radical was going to divide by the radical. And as soon as that's true, we can simplify our fraction. Look at B. Now we have numbers, and now we have radicals. Look at the numbers divided by the numbers. If you have 4 divided by 8, 4 and 8 both divide by 4. 4 divided by 4, 8 divided by 4. 4/8 is the same as 1/2. Root 80, root 10. Radical divide by radical. 80 divides by 10. 80 divided by 10 is root 8. So what I really have is I really have the square root of 8 divided by 2. If this was just algebra like we did in our previous examples, we could be done our question. But because we have the square root of 8, we are going to do the extra steps, which is to simplify that. Again, this 8 is 4 times 2, so the square number, divided by that whole number 2 still. We know that the square root of 4 can be simplified. We can simplify that by putting a whole number 2 here, putting whole number 2 up square root of 2, and we still had the 2 in the bottom. So what happens now? Two 2's, whole number 2 and whole number 2, this 2 and this 2 divide each other. The same way the 4 and the 8 divide each other before, number divided by number, those two 2's, whole number 2's divide, and our final answer square root of 2. So I want you to stop the video, and I want you to try questions C, D, E, and F. And when you come back to the video, what you should see right after you're done is I'll have the answers here for you. So please pause the video, give yourselves 3 or 4 minutes to kind of work through these examples. All right, so in my previous instructions, I said we're going to have you do C, D, E, and F. I've asked in my sub-notes that we only looked at C and D. When we look at C and D, we recognize 125 and 5 both divide out. They both divide by 5. Root 25 is whole number 5. Root 1 is just 1. 5 with root 96 and root 12. 96 divided by 12 is 8. Root of 8 is 2 root 2. So we have 10 root 2. So hopefully you guys found those two answers. Looking at E. E is different than A, B, C, or D because 24 doesn't divide by 5. So we're probably thinking we're done this question, but we're not done the question. What we have to do to simplify is we can only have either a radical on the top of the fraction or the bottom of the fraction. We can't have that square root sign on both the top and the bottom. So when we're in grade 10 and grade 11, we always want to take the radical out of the bottom of the fraction. And the way we can get rid of a radical is we multiply a radical by itself. If you take a radical and times it by itself, kind of neat things happen. If you try this on your calculator, if you take the square root of 5 times by the square root of 5, you get kind of a decimal number times a decimal number, but that equals whole number 5. And the question is, or the math behind it is that 5 times 5 is 25, and we know the square root of 25 is 5. So if we're ever trying to simplify a radical in the bottom because it doesn't cancel out with what's in the top, we can use this trick, this mathematical process of a radical times by itself. That says itself there somewhere. So what we want to do in this question is I want to times the bottom of the fraction by root 5 and times the top of the fraction by root 5 because I always have to treat my fractions equal. Divide them by the same number or multiply them by the same number. So when I go to do this question now, I have 3 and 24 times 5. I want to work that out. And on the bottom, 2 with 5 times 5, I want to work that out as well. But 24 times 5 is going to be 120. So our idea right now is to simplify so that the radical in the denominator goes away. And so we're using that idea of multiplying by itself to get us up, I guess, what we call a rational number. So in the top, I'll come back to the 120 in a second. The bottom is the important part right now. I have 2 times 5. I'm going to leave the top just again for a second. I want to go 3 over 10. So that's what we call rationalizing the denominator, only having a square root left in the top. I want to do the math that helps me simplify the root 120 as well. So if you think back to all the numbers we've done with multiplying to get mixed numbers, 120, that was a bit of a tough one, but we're going to use 4 times 30. And we know that when we take the square root of 4, that's just whole number 2. So if we want to go 3, instead of square root of 4, we're going to write whole number 2. I still have the square root of 30. So when I'm finished this question, my final answer is, well, not quite final answer, but my near final answer is 6 square root 30 divided by 10. You do not divide the 30 and the 10 because that's a whole number with the radical. You can only divide the 6 and the 10 because that's whole number with whole number. So 6 and 10 both divide by 2. So I have 3 square root 30 divided by 5. So this is the challenging part again about math, is we take 1 or 2 skills and we start applying them to questions. What was new in this question? You had the square root of 5. You couldn't cancel it out. So we times top and bottom by root 5. We used our multiplying skills. We had 120. We had root 25. We used our simplifying radical skills to simplify those two numbers. And in the end, we had to simplify our fraction as well. So we're using fraction skills, radical skills, multiplying skills, mixed radical skills. So many skills to use. Question like F. Let's go back to the idea that whole times whole and radical times radical, because that's still the first thing you want to look at. 30 and 8 both divide by 2. 30 divided by 2 is 15. 8 divided by 2 is 4. Like it. I like it a lot because square root of 4 is a whole number. I recognize that from my number. So I divide by 2. I didn't have to multiply a radical by itself this time to make it go away, because canceling out the 2 with the 30 gave me a whole number. Hey, how about this? 2 divided by 2, whole number, whole number. My final answer is square root of 15. I hope you're hanging on here, right? So that's what we're doing. We're looking at questions where you have radical divide by radical. Some radicals cancel out perfectly with radical divide by radical. Sometimes we have to use the skill of multiplying a radical by itself to help us simplify the expression. Sometimes we can just divide and then simplify. Let's try the next page because we have another layer of questions we're going to look at here right away. I want you to try A and B on your own. I want you to look for number divide by number, radical divide by radical. If things still don't simplify perfectly, then multiply the radical by itself. Let's pause again, take a couple minutes, try some of these on your own. All right, you've had a chance to hopefully look at A. 10 divided by 2 is 5, and 12 divided by 2 is 6. 5 root 6 is your final answer. There's no radicals in the denominator. It's simplified. Root 6 doesn't simplify. 15 divided by 5, look at B. 15 divided by 5 is 3, whole number 3. 24 and 18 both divide by 6. 24 divided by 6 is 4. 18 divided by 6 is 3. Square root of 4 is perfect number or whole number 2. So instead of writing 3 root 4, I wrote 3 times 2, and 3 times 2 is 6. I still have that root 3 in the bottom. So to get rid of this denominator, I multiply the bottom by root 3, by the top by root 3. I always treat my fractions equally. What I do to the bottom of the fraction, I do to the top of the fraction. Root 3 times root 3 in the bottom ends up being root 9. And we know that root 9 is whole number 3. Root 3 on the top doesn't simplify, right? They don't go together. But what I do have now is I have whole number 6 and whole number 3, both divided by 3, which is where the 2 came from. 6 divided by 3 is 2 root 3. Perfect. A couple more examples to look at. C and D. Again, this is a little bit different now because suddenly you have 2 terms in the top and only a single fraction in the bottom. But what I want you to do is I want you to look at all the whole numbers. So there's 3 whole numbers in question C, a 4, an 8, and a 2. There's 3 radicals. There's root 6, root 18, and root 6. I want you to look at these and figure out, can you take the fractions and can you divide 4 root 6 by 2 root 6? Can you take 8 root 18 and divide it by 2 root 6? And the answer is yes, you can. 4 divided by 2. So if I look at this 4 and this, I get 2. This root 6 and this root 6 divide out to give me square root of 1 or root 1. I'm just going to leave that alone. But I can't do it with just one fraction. I have to make sure I take this 2, divide it by this 8. So that becomes 2 plus 4. And this root 6 and this root 18 becomes root 3. So I have now taken and divided 4 root 6 by 2 root 6. I should have 2 root 1 here, but we don't write root 1. And I've taken 8 root 18 divided by 2 root 6, I got 4 root 3. In doing that, I've actually divided the bottom expression. I divided it by itself. If you divide something by itself, you get 1. So this question for C then ends up being not even a fraction because we don't usually write things over 1. It's just 2 plus 4 square root 3. So very similar skills. It's still whole number divided by whole number, radical divided by radical, but now you can't do it with just one set of the numbers. You have to do it with all the numbers. So if we look at D, look at 12, 15, and 3. Those are your whole numbers. They all divide by 3, so we're going to divide each of those whole numbers by 3. 12 divided by 3, 15 divided by 3, 3 divided by 3. Root 60. Root 60 divided by 5 is root 40 divided by 5 is root 8. Root 5 divided by itself is 1. So I have 4 root 12 minus 5 root 8 over 1 times 1, because the numbers divided by the numbers and the radicals divided by the radicals. I can simplify it. If this was algebra, we'd be done. But we're not doing algebra. We've got root 12, we've got root 8, and I'm going to get rid of the bottom of the fraction because it's just 1 times 1. So if we take this expression, 4 root 12, and I'm just going to group this together, make it a little smaller for us here. If I take 4 root 12 and 5 root 8, I just need to remember to go 4, and 4 times 3 is 12, and 8. Or if we want to simplify, I want to. So instead of going 4 times 2, I was going to write 8 square root 3. This will be 2 is 1, 2. So that is our answer. 8 root 3 minus 10 root 2. That is done. There is only radicals in the top of the fraction. In fact, the bottom of the fraction is actually gone. Perfect. So how is this different from E? E this time, numbers divided by numbers is good, but radicals divided by radicals doesn't work. So let's try it first of all. Numbers divided by numbers. 4 divided by 2 is 2. 10 divided by 2 is 5. 2 divided by 2 is 1. But now I have root 2, root 6, and root 3. Root 2 does not divide by root 3. 6 does, but 2 doesn't, so I can't just cancel out one of the terms. I have to go back to that other skill, that new skill, which is multiply the bottom by square root 3, multiply the top by square root 3. Whatever you do to the bottom, do to the top. We're going to test your algebra skills here again. Let's just do the bottom first of all. Root 3 times root 3, root 9. When I simplify that bottom fraction, I now have whole number 3. So that's the bottom. Root 3 times root 3, root 9. Root 9 is whole number 3. What does the top look like? When you start thinking about algebra and you think back to what you did in Math 10, if you had some number outside two other numbers, that number on the outside didn't multiply by just once, it multiplied by both. So root 3 has to times by both the numbers in the top of the fraction. I want to take 2 root 2 times root 3. 2 root 2 times root 3. Numbers times numbers, so the 2 doesn't change, but root 3 times root 2 gives me root 6. So 2 root 2 times root 3 is 2 root 6. I want to do the second set of numbers, the 5 root 6 and the 3. The 5 and the root 3 don't go together, but 5 times 1 go together. 5 times 1 is still 5. Root 6 times root 3. Root 6 times root 3 is root 18. So my new top is 2 root 6 minus 5 root 18. 2 root 6 is done. There's nothing else I can do with 2 root 6. We're just going to write 2 root 6. Unfortunately, root 18 is times 2. When you have 18s, when you have 12s, you have to simplify those numbers. So before we're finished, this 9 has to come out, and it's going to become one of those 3s again. If we keep going, keep extending my page, my fraction now is 2 root 6. 5 times 3 is 15. Root 2 divided by whole number 3. Crazy as it sounds, that is your final answer. The whole number 2 does not divide by whole number 3. I can't simplify that anymore. Yes, the whole number 15 divides by 3, but you can't do only 2 of the numbers in the top. You have to do both the whole numbers in the top. And please don't divide the radical by the whole number, because radicals have to go with radicals, whole numbers have to go with whole numbers. So 4 root 2 minus 10 root 6 divided by 2 root 3. Numbers divide by numbers, radicals divide by radicals. If you still have a radical on the bottom, you times the bottom by the radical. That makes it equal itself. Root 3 times root 3 will always equal whole number 3 in the end, because 3 times 3 is 9, square root of 9 is 3. One more example. See if you can do this on your own. Again, you've got a 5, the root 14, and root 20. See what you can do with this. Hey, let's see how you did. There's a variety of ways to do this. I picked multiplying the bottom by root 20 and the top by root 20, just so that I could get square root of 400, and the square root of 400 turns into whole number 20. Root 20 times root 20 will give me 20. When I multiply the top by root 20, I have to make sure I go 5 times root 20 and root 14 times root 20. So that's where 5 root 20 and root 280 come from. Then I have to use my multiplying skills. 4 times 5 is 20. 4 is a square number. 4 times 70 is 280. 4 is the only square number in 280. What we look at again is we take the square root of 4, and that's 2. So that's why it's 5 times 2. 4 times 2 times root 70. When I go to simplify this, 5 times 2 is 10, so I have 10 root 5. 10 root 5 plus 2 root 70. All divide by 20. Now there's no more radical divide by radical. I still need to look at the whole numbers divide by whole numbers. 10, 2, and 20 all divide by 2. So I divide 10 by 2, I divide 2 by 2, I divide 20 by 2. And that's where my final answer of 5 root 5 plus root 70 divided by 10 comes from. Lots of skills when it comes to dividing. You've got a worksheet to work on. You've got some textbook questions to work through as well. Give it a shot. Have fun. We'll see you in the morning.